Good day, esteemed panelists, mentors, and fellow researchers. We are Group 2, and today we are honored to present our research titled Upcycling Agricultural Byproducts into High-Value Consumer Goods, a case study on rice husk-based packaging materials. This study addresses two critical issues: the growing environmental crisis caused by plastic waste and the underutilization of agricultural byproducts. By combining sustainability and innovation, we aim to contribute to solving these pressing problems. Thank you for giving us this opportunity to share our findings with you. Before we proceed with our presentation, let me first introduce our group. I am JanellaG.Manlapaz, the leader of the group. Joining me today are my team members, AngelieAnneT.Bandojo, RonChristianY.Mesina, KatrinaC.Pacson, and CharaEireneP.Uy. Each of us contributed to this research and will present different parts of the study. Thank you, and let's begin with the presentation. Plastic pollution is one of the most pressing environmental challenges today. Millions of tons of plastic waste are produced annually, most of which end up in landfills and oceans. These plastics take centuries to decompose, causing severe harm to ecosystems and human health. The packaging industry is a significant contributor to this problem. As consumer awareness grows, there is increasing demand for sustainable alternatives that reduce waste and carbon footprints. Our study focuses on rice husks, an agricultural byproducts of rice milling. Rice husks are often discarded or burned, releasing harmful pollutants. By transforming rice husks into eco-friendly packaging materials, we aim to address environmental concerns by promoting a circular economy.
Our study is guided by three key objectives. First, to identify the technological and operational requirements for producing rice-based packaging. Second is to explore innovative approaches for improving production efficiency and sustainability. Third is to analyze the market demand and feasibility of rice-based packaging materials. By addressing these objectives, we hope to demonstrate the viability of rice-based packaging as a sustainable alternative to plastics. This research has a wide range of benefits. For customers, it offers safer, eco-friendly packaging options, particularly for food and consumer goods. For rice milling businesses, this study serves as a valuable resource to utilize rice husks as a raw material that can create an additional stream of income for rice mill businesses. For small businesses, sustainable packaging helps improve brand image and attract eco-conscious consumers. For researchers, it opens doors for further studies on upcycling agricultural byproducts. In essence, this study addresses environmental concerns while creating opportunities for economic growth and innovation.
Our research was conducted in San Isidro, Nueva Ecija, a major rice husk producing region with an abundant supply of rice husk. We used mixed methods approach involving surveys. Data were collected from 35 respondents, including small business owners, customers, and researchers to evaluate market demand and perceptions. Experiments. We developed a step-by-step process to create rice husk-based packaging materials and tested their feasibility. Qualitative feedback. Open-ended responses provided insights into the strength and limitation of the product. This comprehensive approach allowed us to assess both the technical and market feasibility of our innovation. Our production process is straightforward and includes the following steps. Preparation. Rice husk and banana peels are washed and boiled to soften them. Pulping. The softened materials are blended in the pulp. However, we face challenges during these steps due to the limited grinding equipment which affected the textures for the final product. Molding and shaping. The pulp is poured into the molds to shape into the sheets or desired forms. Drying and inspection. The molded materials is dried into the well-ventilated area or under the sun and inspected for imperfections like crack or uneven edges. This process makes use of locally available resources, promoting both accessibility and sustainability.
Our findings on technological feasibility reveal that rice husks are readily available in Nueva Ecija, scoring 3.20 on our Liker scale. However, the processing stage posed challenges, particularly during grinding due to the fibrous nature of rice husks and the lack of advanced equipment. Despite these challenges, the overall feasibility is scored 2.85, This indicates that while the production process is promising, improvements in technology are necessary to optimize efficiency and quality. Next, we assess environmental and labor feasibility. Environmental compliance, the production process scored 3.20, demonstrating alignment with sustainability goals. It generates minimal waste and utilizes biodegradable materials. Labor requirements, with a score of 3.40, the process is manageable using existing skill and has the potential to create local employment opportunities. These findings highlight the process, environmental friendliness, and accessibility for local communities.
Our market feasibility analysis was highly encouraging. There is a strong demand for sustainable packaging materials reflected in a mean score of 3.48. Businesses showed interest in switching to eco-friendly packaging, and consumers expressed willingness to pay a premium for environmentally friendly products. However, significant challenges remain. Pricing, limited availability, and competition with traditional plastics are barriers that need to be addressed for widespread adoption. While our research showed great potential, we encountered some challenges. First is resource limitation. The lack of advanced grinding and drying equipment affected the texture, thickness, and durability of our product. Next is product limitations. The material absorbed moisture and lacked flexibility, making it less suitable for certain packaging applications. This limitation highlights the need for further refinement in both the production process and the materials used.
In conclusion, rice husk-based packaging offers significant potential as a sustainable alternative to plastic. It addresses environmental concern by reducing waste and pollution. It creates economic opportunities for rice millers, small businesses, and local communities. However, achieving scalability requires overcoming technological challenges and addressing market barriers. With continued innovation and support, rice husk-based packaging could become a key player in the sustainable packaging industry.
Based on our findings, we propose the following recommendations. First, invest in better equipment. Advanced grinding and drying machinery will improve product quality and consistency. Second, develop sustainable additives. Additives can enhance the durability, flexibility, and moisture resistance of the packaging. Third, conduct further market research. Expanding into new applications and identifying additional consumer segments will help maximize market potential. We would like to express our heartfelt gratitude to our mentors, Nueva University of Science and Technology, and the local community of San Isidro, Nueva Ecija, for their invaluable support throughout this research journey. Thank you for your attention. We are now open to your questions and feedback.
Question from Dr. Annalyn M. Gamit. How does the use of banana peels as an additive in rice-based packaging improve the product's properties? And what alternatives could be explored for further enhancements?
Thank you, Dr. Annalyn M. Gamit, for the question. The use of banana peels as an additive in rice husk-based packaging improves the product's properties by enhancing its binding capabilities, increasing flexibility, and aligning with eco-friendly goals. Banana peels contain natural starches and fibers that act as a binder, improving the cohesion of the rice husk mixture and ensuring better structural integrity. Additionally, they add elasticity, reducing brittleness and making the packaging more versatile for various applications. To further enhance the material, alternatives such as cornstarch, agar, coreginan, biodegradable polymers like PABA, natural resins, or recycled paper pulp could be explored. These materials can improve strength, flexibility, water resistance, and durability while maintaining the product's sustainability. By integrating such alternatives, the overall quality and market potential of the rice husk-based packaging can be significantly increased.
Here's the question from Dr. Joy N. Salveliano. Given the raw textures and limited flexibility of the initial product, what strategies would you recommend to improve the usability and marketability of rice husk-based packaging?
Thank you, Dr. Joy and Sevillano, for that question. To improve the usability and marketability of rice-based packaging, I would suggest blending it with eco-friendly materials like PLA or polylactic acid, or seaweed-based bioplastic to enhance flexibility. Smoothing the texture and adding appealing designs can also make it more attractive. Highlighting its eco-friendly benefits will help attract environmentally conscious buyers. And finally, partnering with brands and educating consumers about its sustainability can increase its market appeal.
Question from Dr. Marilu P. Pascual. What specific challenges did you encounter in the production process, particularly regarding the grinding of rice husk, and how can these challenges be addressed in future studies?
Thank you, Dr. Marilu P. Pascual, for the question. The challenges we encounter in making rice husk packaging materials are: we couldn't turn the rice husk into the paper despite the multiple attempts because the rice husk wasn't crushed finely enough. The large particle caused the materials to break easily when dried under the sun. We didn't use enough banana peel in the mixture, making the materials weak and prone to breaking when touched or handled. The silkscreen we used had large hole or big hole, resulting in poor quality and unfinished rice husk paper. To solve these challenges, we ensuring the rice husk is ground into the very fine powder. We use 50-50 ratio of rice husk and banana peel, as the banana peel helps to bind the paper together, using a silkscreen with very small hole to improve the texture and the quality of the rice husk paper. This will create better rice husk paper for packaging materials.
Question from Dr. Jennifer G. Fronda. What potential partnership or collaboration could be formed with local rice mills or government initiatives to scale up the production of rice husk-based packaging material?
Thank you, Dr. Jennifer G. Fronda, for the question. The marketing of rice husk as a packaging material can grow through strategic collaborations with the local rice millers, ensuring a steady and sustainable supply of raw materials while addressing a significant waste disposal issue. By partnering with government initiatives, research and development institutions, and packaging companies, new technologies can be introduced that enhance the viability and scalability of rice husk-based packaging, ultimately creating a robust market and boosting industrialization. Additionally, working alongside non-profit organizations can raise awareness, secure funding, and facilitate deeper market penetration. This collaboration will not only accelerate the growth of green packaging solutions, but also play a critical role in transitioning and packaging industry toward more environmentally sustainable materials. The combination effort could reduce reliance on petroleum-based plastic essence, environmental impact, and foster innovation in circular economy models.
Here's the question from Dr. Nestor Natividad. How does the environmental impact of rice husk-based packaging compare with traditional plastic packaging? And what metrics do you use to assess sustainability?
Thank you, Dr. Nestor Natividad, for the question. Rice husk-based packaging is generally more environmentally friendly than traditional plastic packaging. When comparing the two, rice husks produce less carbon dioxide because they come from a byproduct of a rice farming, which requires less energy to process than plastic made from oil. Rice husk packaging is also biodegradable, meaning it breaks down naturally, while plastic can take hundreds of years to decompose, often causing pollution in oceans and landfills. The energy used to make rice husk packaging is lower compared to plastic, which needs a lot of energy to produce and recycle. We measure these impacts using metrics like carbon footprint, the total greenhouse gases produced, energy use, how much energy is required to make the packaging, and waste impact, how much waste is left after use. Overall, rice husk packaging has a smaller environmental footprint, especially when it comes to waste and energy use, though its impact can still depend on how it is managed after use.
On behalf of our group, thank you for listening to our presentation and engaging with us during the Q&A. This research highlights the potential of sustainable innovations like rice husk-based packaging in addressing environmental and economic challenges. We hope our work contributes to meaningful change and inspire further efforts towards sustainability. Thank you.